Okay, look at our example. Locate all the critical points of f equals to blah blah blah. Then determine whether the critical points have a local minimum value, local maximum value, or a saddle point. Okay, so step 1, to find critical points. Okay, our step 1. Okay, we have to find fx, fxx, fxy, fy, and fyy. Okay, so our fx equals to, okay, so here 1 times y plus 3 x 3x squared okay, minus 0 plus 0, which is equals to y plus x squared. Okay, next find fxx equals to, okay, look at here. Okay, differentiate y with respect to x, it becomes 0. Differentiate x squared with respect to x is 2x, so equals to 2x. Next, find fxy. Okay, now differentiate our fx with respect to y. So y, differentiate y with respect to y comes 1. Differentiate x squared with respect to y comes 0. So equals to 1. Okay. Next, find fy. Okay, so here will be x times 1 plus 0 minus 2y over 2 minus 2 plus 0. Okay, simplify this, you will get x minus y minus 2. Okay, next find fyy. Okay, so differentiate x with respect to y becomes 0. Differentiate y with respect to y becomes 1. differentiate -2 with respect to y, 0. So equals to -1. Okay, next step. Okay, step 2. Okay, so step 2, solve for fx equals to 0 and fy equals to 0. Okay, so our fx just now is y plus x squared. Okay, equals to 0. And then our fy equals to x minus y minus 2, and then let it be 0. Okay, so we are going to solve our equation. Okay, so by substitution. Okay, so this one y equals to 2, okay, negative y, 2 minus x. So y equals to -2 plus x. Okay, so take this and then just substitute into equation 1 here. So we will get -2 plus x squared equals to 0. Okay, and then rearrange this to make sure it is in order, and then you just use your calculator for quadratic. Okay, and then you will get your x equals to -2, 1. Okay, so when your x equals to -2, y will be -2 plus -2, which is equals to -4. Okay, so you will get the critical point here, -2, -4. And then x equals to 1. Okay, so y equals to, okay, substitute into here, -2 plus 1 equals to -1. So the critical point is 1, -1. Okay, so we have already located our critical points here. Okay, we proceed with step 3. Okay, where we want to determine whether our critical point is maximum, minimum, or saddle points. Okay, so for step 3 here, we have to compute. Okay, compute fxx ab fxy ab and fyy ab. Okay, so we have two critical points, so we just simply split into 2 by here. Okay, so we have critical point. The first one is -2, -4. The second one is 1, -1. Okay, so we have at xx equals to x. So fxx -2, -4 equals to 2 times -2, okay, which is equals to -4. Okay, next we find fxy, -2, -4. Okay, what is our fxy from the first step? 1. Okay, so no variables involved here, only 1, so the value is fixed to be 1. Next, fyy, -2, -4. Okay, so we have our fyy also fixed to be -1. Okay, so here for fxx 1, -1 equals to 2x. What is our x value here? 1. So 2 times 1 equals to 2. Next, fxy at 1, -1 fixed to be 1. fyy at like 1, -1 also fixed at -1, fixed value. Okay, so we finish our step 3. Okay, we continue our step 4. Okay, is compute G at critical point AB. Okay, so we have 2 points, -2, -4, and 1, -1. Okay, so our G, -2, -4 was 2. Okay, so we take all the values. Okay, so fxx at the point -4, fxy at the point -2, -4 is 1. If it is 1, then it is 1 also here. Okay, so fyy at the point -2, -4 equals to -1. Okay, so find the determinant. Okay, so -4 times -1 minus 1 times 1, which is equals to 4 minus 1 equals to 3. Okay, so next find for g at critical point 1, -1. Okay, fxx at 1, -1 is 2. Okay, so fxy at 1, -1 is 1, 1, and fyy at 1, -1 is -1. Okay, then find the determinant. 2 times -1 minus 1 times 1, which is equals to -3. Okay, step 5. Okay, so step 5, to make our decision, we refer to our theorem here. Okay, so we have 2 points just now. Okay, so 2 critical points. Okay, at these critical points, our G equals to 3. Okay, which is greater than 0. And fxx at this critical point, we calculate before, which is -4, which is less than 0. This concludes that f -2, -4 is a local maximum value. Okay, so for 1, -1 here, g1, -1 equals to -3, which is less than 0. Okay, so when it is less than 0, then we conclude that okay, less than 0. So satisfy this condition. So f1 negative 1 is a saddle point. Okay, so we finished already. Okay, then proceed with activity 1 and activity 2 at home.